Hi class, in this video we will be reviewing the Pythagorean theorem for right triangles. What the Pythagorean theorem tells us is that a squared plus b squared is equal to c squared. And the key is that this c value right here has to be the hypotenuse of the triangle. So c is the hypotenuse, and the hypotenuse has got to be across from the right angle of the right triangle. So that's the long side has to be the hypotenuse. The other two sides are legs. So in this problem, we're looking to find c. So we could set this up as 3 squared for a squared plus 4 squared equals c squared, finding c the hypotenuse. So solving this, 3 times 3 is 9, plus 4 times 4 is 16, and that's equal to c squared. So solving this problem, we have 9 plus 16 is 25. So 25 is equal to c squared, but in order to find c, we have to square root both sides, and we'll get that c is equal to 5. So the length of the hypotenuse is 5. Solving this problem, we're looking to find the long side, which is the hypotenuse right here. So that side has to be c, so we can write a squared plus b squared is c squared. And we can write that 12 squared plus 5 squared has got to be c squared. So finding that value, 12 times 12 is 144. 5 times 5 is 25. So adding the numbers together, we'll get 169 is equal to c squared. Square rooting both sides, c is equal to the square root of 169, which is 13. So the length of that value there is 13. In this problem, we're trying to find x, but the first thing I notice is that x is a leg, and it's not the hypotenuse. So the side across from the right angle, the 14, has to be c. So when we set up a squared plus b squared equals c squared, then this problem will be 11 squared plus x squared is equal to 14 squared. So the key is the 14 has to be at the end, the c squared. So multiplying these, 11 times 11 is 121 plus x squared is equal to 14 times 14, which is 196. So solving this problem, now we have to solve for the x squared. So we have to undo the plus 121. So minus 121 to this side, minus 121 to the other side. And we'll get x squared is equal to 75. So now square rooting both sides, we'll get that the length of x is equal to the square root of 75, which is approximately 8.66. So that's our answer. That's the length of this missing side is 8.66. And that makes sense in the context of this problem because the 8.7 and the 11 are both shorter than the longest side, which is the hypotenuse, which is 14. If you got an answer larger than 14, you would know to check your work. So now let's take a moment and calculate x in this right triangle using the Pythagorean theorem. Here we have two problems, 1 and 2. For the first problem, it says, what's the length of the hypotenuse of triangle ABC? So here's triangle ABC. We're looking for the hypotenuse, x. Okay, so using a squared plus b squared equals c squared, we'll have 20 squared plus 21 squared is equal to c squared. So we're solving for c. Okay, so 20 squared plus 21 squared, I could type that directly into the calculator, and I get 841 is equal to c squared. So now I'm going to square root that, and I get that the square root of 841 is equal to 29. So 29 is the hypotenuse. In this problem, we don't have a triangle, but we have to draw one in. It says the legs of a right triangle have lengths of 10 and 24. So those are the legs, are 10 and 24. Here's my right angle, and I'm looking to find the hypotenuse right there, the long side. Okay, so solving this, we'll have 10 squared plus 24 squared is equal to c squared. So solving for c, 10 squared plus 24 squared equals 676. 676 is equal to c squared. So when I square root that, I'll get that c equals 26. So that's the length of the hypotenuse. In this problem, we're finding the length of x. So the first thing that we want to do is identify the hypotenuse. And the hypotenuse here is 20, so that's c. So when we set up this problem, we're going to have a squared plus 8 squared equals 20 squared. So the key is to make sure that the hypotenuse is at the end. That's the main idea of the lesson. So solving this, a squared plus 8 times 8 is 64 is equal to 20 times 20, which is 400. So solving that, when you subtract 64 to both sides, you'll get a squared equals 336. So square rooting both sides, we get that this x value here is 18.33. So that's our answer. In this problem, we're given the hypotenuse and we're given one leg, so we're looking to find the length of the other leg. So go ahead and draw in a right triangle and then find the length of that other leg. This last problem, we're given a word problem. This says the size of a computer monitor is the length of its diagonal. You want to buy a 19-inch monitor that has a height of 11 inches. So what's the width of the monitor? Okay, so to figure out this word problem, let's draw a picture. So we have a computer monitor. And it says that the length of its diagonal is 19. So that the diagonal is going to be this distance right here. And that's 19 inches. And then the height of the monitor is 11. So what we're looking for is the width of the monitor, which is this distance right there. So in this problem, since this makes a right angle, we can use the Pythagorean theorem and just look at that red triangle there to find the length of that leg. The key is that this 19 is the hypotenuse, c. So we have a squared plus b squared equals c squared. So filling things into that, we'll have x squared plus 11 squared is equal to 19 squared. So finding that, x squared, so 11 times 11 is 121. And 19 times 19 is 361. So now we want to subtract 121 to both sides. And we'll get 240. So that tells us that x is equal to 240. So let's square root both of those sides to get x by itself. So the square root of 240 is 15.5 inches. So 15.5 inches. So that has to be the width of the screen right there, is 15.5 inches. It turns out in geometry, we're really going to use the Pythagorean theorem a whole lot to find missing sides of right triangles, and usually in word problems or some other context. All right, thanks for watching.